In section 7.4b, I want you to be able to use some more properties to simplify logarithmic expressions and translate between logarithms in any base. So you can tell by looking at the graphs of exponential and logarithmic functions that they are inverses of each other. And since they are inverse operations, they undo each other. So there's two more properties I want to go over today. And you can see them both right here. They have to do with if the base is the same as the number that follows the base, then your answer is your exponent. And you can see that a couple of different ways. If you look down here, the base is the same as the number that follows the base. If that's the case, then your answer is the exponent. So here, the answer is just 11. And I can show you with one of the other properties that we learned the other day that that's true. If you have an exponent, remember we had another property that said you can bring the exponent out in front of the logarithm, so it would become 11 log base 3 of 3. And log base 3 of 3 is just the number 1, because we're asking ourselves what power do we raise 3 to get 3 back, and that would be 1. So we would have 11 times 1, which just is the number 11. So you can get that answer either way a little faster, just to notice that the base, if the base and the number that follows the base are the same, the answer is the exponent. The second one also has to do with looking at the bases. Here we have a base that's raised to a logarithm, and the two bases here are identical. If that's the case, then the solution is just 4. The second thing that I want to go over is the change of base formula. And we already mentioned that most calculators can calculate logs in base 10. Only, or, and I didn't talk about this yet, base E. And we're gonna go over that in section 7.6. So you can change a logarithm in one base to a logarithm in another base with the change of base formula. And we're going to today change to base 10, so you can enter that in your calculator. So the change of base formula says that if you have one logarithm, whatever the base is, you can rewrite that logarithm as 2 logarithms, and the base gets rewritten in the denominator as a logarithm. So we have 2 individual logarithms, and it might just be easier to show you with an example here. Always put this base in the basement, so in the denominator. And here's an example. We have log base 32 of 8, and we're going to rewrite it into 2 logarithms like this. We're going to write the logarithm as 1 logarithm divided by another logarithm. So I mentioned up here we're going to put the base in the basement, and you always have to write the log in front of both of them. So in the numerator we're going to have log, and we're changing it to base 10. We're changing it to base 10 so you can enter that in your calculator. Now you want to be really careful. Most calculators, when you enter log base 10 of a number, parentheses will pop up. You need to make sure, very, very important, that you close that parenthesis. If you don't close the parenthesis, then you're going to get a different value, and I'll show you that in just a minute. So log base 10 of 8, close that parenthesis, divided by log base 10 of 32, and when you do that, you're going to end up with the answer of 0.6. Now, if you don't close the parenthesis, so if you enter it into your calculator as log base 10 of 8 divided by log base 10 of 32, you're going to come up with approximately 0.73. So those two answers are not the same. Make sure you close the parentheses. And as you can see off to the side here, let me slide it over a little bit. When you write it like this, both logs now have base 10, so that allows you to enter them into your calculator. Okay, there's a couple of questions for you to try.